Hello everyone, I am Bhavani Bahaduri. First of all, I would like to thank Emertxe Information Technology for providing this wonderful internship on embedded system. Today I am going to present on microwave oven. Here are the contents, which includes concepts learned, project overview, project requirements, overview of PIC 16F877A, character LCD, matrix keypad, ISR, timer, block diagram of microwave oven, architecture of PIC 16F877A, conclusion. Moving towards concepts learned. In C programming, I have learned data types, conditional statements, loops, arrays and pointers, functions, strings, storage classes, and variables and preprocessor. Coming to the definition of embedded system, it is defined as a system is a combination of hardware and software designed for a specific function. Classification of embedded system. There are 4 types of classes, which includes real-time embedded systems, standalone embedded systems, networked embedded systems, and mobile embedded systems. Coming to microcontroller and microprocessor, where microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system, whereas microprocessor is a controlling unit of a microcomputer fabricated on a small chip capable of performing arithmetic logical unit operations and communicating with other devices connected to it. Coming to the project overview. The project title is Microwave Oven. A microwave oven is an electric oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency range. Here is the diagram of microwave oven. The softwares used in building this project includes MPLAB X IDE, which is used for performing the programming, and MPLAB X compiler is used for compilation, and PIC SimLab is used for the simulation purpose. The project requirements are: I have included different modes of microwave oven, which includes micro mode, grill mode, convection mode, and start mode. Here the user can set timer and temperature, and the user can even start or resume, pause and stop. When the user wants to pause the process, he can pause, and even he can resume it from where he was stopped. And this microwave oven alerts the user by turning on the buzzer when the time is up. So this is the overview of PIC 16F877A microcontroller, and here is the pin diagram, which includes 5 ports, namely port A, B, C, D and E. Coming to character liquid crystal display, which is in short called as CLCD. There are 3 different types of CLCDs, which includes 16:2 display, where 16 is defined as number of columns and 2 is defined as number of rows, and 16x4 and 16x4 characters. It even displays the ASCII character and some special characters. There are 2 types of communication modes. They are 4-bit mode and 8-bit mode. Coming to matrix keypad. A matrix keypad is a circuit that has a grid-like array of horizontal and vertical wires connecting the key switches. If the key features include 4 rows and 4 columns, then it can support up to 16 keys. These keypads are most commonly used in telephones, calculators, digital lockers, etc. ISR. ISR stands for Interrupt Service Routine. The interrupt is a signal emitted by hardware or software when a process or an event needs immediate attention. It alerts the processor to a high priority process requiring interruption of the current working process. When an interrupt occurs, the microcontroller runs the interrupt service routine, that is ISR. Timer. A timer is a device that measures time, especially that is a part of machine, and causes it to start or stop working at specific time. It is a device designed to count the time interval between events. There are two main types of timers, mechanical timer and electronic timer. So, this is the block diagram of microwave oven. Coming to the architecture of PIC 16F877A. It can interface with different components, namely RS-232, LEDs, buzzer, digital keypad, matrix keypad, CLCD, ADC, temperature sensor, and GPIO, and even etc. So, the conclusion of microwave oven project is that microwave heating has been established in a number of industrial sectors. The use of microwave oven provides a convenient way to cook and reheat food nowadays. So, the simulation results are useful for designing microwave oven. This is overall presentation. Coming to the programming part. Here is the program. We can see that I have initialized CLCD matrix keypad. In main function, I have initialized the reset flag character key, and this is the overall program. So let me build it. First we have to go into microwave oven project, and here we have to build. Here the header files should be included into header files, and .c files should be included into source files. After building successfully, we will go to PICSIM where it is used for the simulation purpose. Here is the clock, which is set to 20 MHz, and the LCD is 16x4. Let's reload the last. Okay, it is displaying power on microwave oven. Here are the different menus I have included in the program. If I press key 1, then it will show microwave. If I press 2, then it will be a grill mode. If I press 3, then it is convection mode. If I press 4, then it is start mode. Let me press 1. Okay, it is showing the power, which is 900 watt. Here is the set time, which is in minutes and seconds. First, the numbers entered will be considered as seconds, and next numbers considered will be as minutes. Let me press 21 in seconds. If I press star, then it will be cleared. Now I will press 11. Then I will press hash, which will enter. Okay. Now the time is showing by decreasing, and the fan or the cooler is turned on and it is running. After the time is complete, it displays time up and buzzer will be on. Now I will press grill mode, that is 2. Here is also the same procedure. Now I will press 10 seconds. Now I will enter it. See, after 10 seconds, it will show time up by turning on the buzzer and makes a noise. Now I will enter 3. Here is to set the temperature, which is in degrees Celsius. The temperature is a 3-digit number. It is blinking here. Now the temperature should be entered, which will be less than 180 degrees Celsius. So I will enter 125, which is also less than 180. So here I have entered 127. Now I will press hash. In preheating, I have included the timing as 180 seconds, which is equals to 3 minutes. The timer is decrementing. After completion of timer, it will exit the screen and it will come to the main menu. So until that, let's see here. Here is the main.h file where I have defined the fan, buzzer, door, reset nothing, mode reset, reset temp, and the different modes like micro mode, grill mode, convection mode, start mode, time display, start, pause, stop, whichever I have included in my program have been defined here. And this is the clcd.h, clcd.c, initializing the CLCD, and function put ch and print. Here is the matrix keypad.c program. So this is the program of matrix keypad, and this is the program of timer. There are two different types of timers, that is timer 2 and timer 0. In this this microwave project, I have included timer 2. So here the timer 2 on is kept as off, and lastly this is the ISR program. Okay, next go back to the simulation. The remaining time is 6 seconds. Okay, it has came back. Now let me enter 5 seconds and press hash. Now I can stop it or I can pause it by pressing 5. So the timer has been paused at time 3 seconds. When I press 4, it will start or resume. Okay, it has been resumed. Let me get back to it again. Let me press 5 seconds again. Now by pressing 6, I can stop this. Okay, by pressing 6. Okay, now I have pressed it 56 seconds. Let me enter. The timer is showing as 52 seconds. Now let's stop it by pressing 6. Okay, when we again go back to the timer here, if I enter 21 seconds and then press hash, the timer is showing 17 seconds. By pressing 4, the timer will be get added with 30 seconds more. That is, see, it's been added. So now I will stop it. Now I will press 4, which is start mode. Okay, by entering the start mode, the timer will take it as 30 seconds. Now again I will press 4, which will add on 30 seconds more to it. Okay, now it's become, see. Okay, now I will stop it. So this is overall project I have done during this internship. Thank you.